Kia ora Year 12, hope you're enjoying the first day of the school holidays. I'm going to make some revision questions during the break for you to watch if you run out of maths to do. And if you're off at Space Camp and you're stuck on a bus and you're bored, and you've got a really good data plan, which is pretty unlikely, you could watch these videos too. There will be a spot prize halfway through. The first person to figure out the song will get a chocolate fish when we get back to school. So I've picked 3 little trig questions. The first one is an equation to solve. The second one is an identity. And the last one is another equation, but this time focusing on general solutions. So pause the video and have a go at all 3 of those. Use your notes if you need to, and then come back when you're ready to go. Okay, so the first question is to solve this equation here. 20 sine squared theta equals 7 cos theta plus 2. And I should have said on that first slide, but what I'm looking for here is just the solutions between 0 and 360 degrees. So that makes it slightly easier. It also means I'm probably not going to bother doing general solutions on the whole thing, but we'll get to that further to the end. So you'll see here I've got sine squared theta on the left hand side and I've got cos squared theta on the right hand side. But if I use one of my Pythagoras identities, I can easily turn this into a quadratic in cos theta. So sine squared theta is 1 minus cos squared theta, which gives me 7 cos theta plus 14, expanding out the right hand side. Now collecting up like terms, let's pop in one extra line. 20 minus 20 cos squared theta is 7 cos theta plus 14. So gathering everything up, what do I get? Well, I get 0 equals 20 cos squared theta plus 7 cos theta minus 6. So just looking at that, we've got a quadratic in this form. And if we want to factorize that, we can use grouping. So we want 2 numbers that times to give me negative 120 and add to give me 7. So those 2 numbers would be 15 and negative 8. They'll work. So I'm going to split that quadratic up as follows now. Oh, I keep running to 20 cos squared theta. Now we'll split that middle term into a plus 15 cos theta minus 8 cos theta minus 6. Now I factorize in 2 steps, which gives me 0 equals, well, we've got 5 cos theta into 4 cos theta plus 3 minus 2 into 4 cos theta plus 3, giving me 5 cos theta minus 2 times 4 cos theta plus 3. So the next step is to solve each of those equations. Right, remember my strategy when I'm solving equations is usually to try and get 0 equals and then the product of 2 factors. So if this is 0, the whole thing will be 0, and if this is 0, the whole thing will be 0. So I'm going to do that on the next slide because I want room to sketch the cosine theta graph roughly. Okay, so 5 cos theta minus 2 equals 0 gives me cos theta equals 0.4 or 2/5, or 4 cos theta plus 3 equals 0, cos theta equals negative 3/4. Now neither of those have got nice solutions, but let's just have a little look at my cosine function. So that's cosine between 0 and 360. So let's mark in the solutions we're after. Well, 0.4 is about here, so we're looking for this solution and this one, We're going to use symmetry to get it. Over here, we're looking for where is cosine theta equal to negative 0.75. So it's going to be this value and this value. So theta is equal to cosine inverse of 0.4, which is 66.4 degrees. So that's the first solution. And the second solution, 360 minus 66.4 degrees, which gives me 293.6 degrees. Over here, we get theta equals cos inverse negative 0.75, giving me 138.6 degrees for this first one here. And then by symmetry, well, a few different ways to do that, but we could just do again 360 degrees minus 138.6, and that equals 221.4 degrees. So we've got those four solutions. So let's write them out nicely in order. 66.4, 138.6, 221.4, or 293.6 degrees. Okay, so four solutions to that one. All right, on to the next problem, which was my trig identity question. All right, but just before we do that, here is the mystery sound clip. First person to figure out what it's from gets the chocolate fish. So listen up, because as you know, my microphone is pretty terrible. There you go. I'll give you a clue. Song relates to current activity of about half the class. Okay, so this question, sec, we want to show that sec 7 pi on 12 is equal to negative root 2 minus root 6. So, what can we say about sec of 7 pi on 12? We've got to break this down. Well, sec is 1 over cosine. So it's 1 over cosine. Now, what can we do with the 7 pi on 12? Well, a good place to turn when we're doing trig identities is our compound angle formula. And we can see that 7 pi on 12 is 3 pi on 12 plus 4 pi on 12. And we like both of those because they're our special triangle numbers, and they're going to give me some nice exact values. So your big clue here, of course, is that we've got a couple of surds in the question, and they come out of my two wee triangles that you've seen over and over. So what I'm going to do here is, instead of working with sec, I'm going to work with cos of 7 pi on 12. Okay, so what can we say? Well, cos of 3 pi on 12 plus 4 pi on 12 is equal to cos, right, 3 pi on 12 is pi on 4, cos pi on 4, cos pi on 3, minus sine pi on 4, sine pi on 3. Now, drawing in your triangles if you need to. Here's 1, root 3 and 2, 1, 1, root 2. What's cosine of pi on 4? Well, it's 1 on root 2. Cosine of pi on 3 is 1/2, minus sine pi on 4, 1 on root 2, minus sine of pi on 3, whoops, pen's gone funny, sorry, root 3 on 2 here, giving me 2 root 2 in the denominator and 1 minus root 3 in the numerator. So if that's cosine of 7 pi on 12, then sec will be the reciprocal of that. So we're going to do that on the next slide. So sec 7 pi on 12 will equal, let's see, 2 root 2 over 1 minus root 3, multiplying by the conjugate surd, 1 plus root 3, so that I can rationalise the denominator, is going to give me 2 root 2 plus, oops, don't know what's happening there, 2 root 2 plus 2 root 6, and in the denominator I have 1 minus root 3 plus root 3 minus 3, giving me 2 root 2 plus 2 root 6 over negative 2, which is negative root 2 minus root 6 as required. Okay, so that's all for now. I'm going to do the general solution one that is on that first slide in a separate video because this is just getting way too long. So I will be back with that as an add-on in about 10 minutes.